All right, we're going to graph general or rational functions today. Again, graphing again today. More rationals again today. So more fraction equations that we're going to graph. So here we go. All right, this is so important. Oh my gosh. Graphs of rational functions. Rational functions, as you know, look like this. Have a numerator, denominator. You can have x's in your numerator, x's in the denominator. The x-intercepts of the graph are the real zeros. Whatever makes the numerator 0, those are your x-intercepts. The graph has vertical asymptotes anywhere the denominator is 0. And the graph has at most one horizontal asymptote, and that's determined by what your degrees are in your numerator and denominator. So I'm going to be talking about that exponent and that exponent a lot today, and also your leading coefficients. So here's the deal. Main thing I want you to get from there are asymptotes. The vertical asymptotes always occur at whatever the zeros of your denominator are. What makes the bottom 0? What makes the bottom be a fraction 0? That's going to be your vertical asymptote all the time. Your horizontal asymptotes, there's 3 cases, and here they are. If your top degree, the degree of your numerator is larger than your denominator, there is no, I'm going backwards, there is no horizontal asymptote. I don't have to worry about it. If they are equal, if the degrees are equal, your biggest exponent, top and bottom are both equal to each other, you do the leading coefficient over leading coefficient, and that gives you your horizontal asymptote. And you're going to see each of these 3 cases here in a second. The last case is, what if your top degree is less than your bottom degree? If your bottom degree is bigger, the x-axis is a horizontal asymptote, or y equals 0. And that's what you saw in yesterday's lesson, was the x-axis is pretty much the asymptote, horizontal asymptote, because the degree was bigger. We didn't have any x's in your numerator yesterday, I don't think. So that's the difference. So one more time. The vertical asymptote, whatever makes your denominator 0. Horizontal asymptote, 3 cases. If the degree on the top is smaller, the x-axis, or y equals 0. If the degrees are the same, you do leading coefficient over leading coefficient. If the degree is bigger on the top, then there is no horizontal asymptote. So it's all about the degrees. Okay, first one here. Always check the denominators and check your degrees out. First of all, what I've noticed is there is no x in my numerator. There's an x squared in my denominator, which means my degree is greater on the bottom, which means a horizontal asymptote. My horizontal asymptote is y equals 0, or the x-axis. And if you look at my graph right here, that means my asymptote will be right there. Notice what the graph's doing, it doesn't touch it. The vertical asymptote is whatever would make my denominator equal 0, but because it's an x squared and you're added 1 to it, there's no way to square something and get -1, so that means there is no vertical asymptote this time, which is why you look at the graph, there's no breaks in it or anything. It's just kind of a smooth curve, goes up and then back down, and that is why that happens. It also said domain and range. Your domain here is, it's going left and right forever, so your domain is all real numbers, or you can write it like that. My range is, it's going from 0 up to, it looks like up to 1, 2, 3, 4, 5, 6. It actually touched the 6, so the range is from 0 to 6. All right, so there's that one. That's one case where where the degree on the denominator is larger than the degree on the numerator, horizontal asymptote 0, or the x-axis. All right, next case. First thing I'm going to do is go ahead and factor that denominator because I can. That's really x plus 3 and x minus 3, and that's a big deal. Also look at your degree. The degree of my numerator is 2. The denominator is 2. The degrees are the same, which that means my horizontal asymptote is going to be leading coefficient over leading coefficient, which would be y equals 2 over 1, or just 2. There's your horizontal. And look at the picture. Sure enough, the horizontal asymptote is at 2. The vertical asymptote, remember, is whatever causes your denominator to equal 0 in this case. And don't forget you put x equals. X equals -3, and also x equals 3. There are 2 vertical asymptotes. Once again, let's look at the picture here. The horizontal is y equals 2. Look where the horizontal asymptote is, right there, y equals 2. The vertical asymptote is x equals -3 right down through there, and x equals +3 right down through there. And the graph gets closer and closer to those points, to those lines, but never will touch them. Also, to make things easier today, we're going to get our points instead of trying to just figure some points out that work really easily. What we're going to do is we're just going to punch those in our calculator in our table, find the points that work in between the asymptotes, and just graph it from there. So the graphing part won't be too hard, but I do need you to know how to find those asymptotes. One more case. Like the last case is, what if your numerator degree is larger than the denominator? In this case, it is. What that means on the horizontal side is that there is not one. There is not a horizontal if that's the case, if your top degree is bigger than your bottom degree. If you look at the picture, you can tell there's no horizontal. Vertical, as always, is whatever makes your denominator 0. In this case, it would be 2, so it's x equals 2. And you can look at the graph right there. Notice the asymptotes going right through x equals 2. Those lines are going by 2s. And again, we're going to find some points to plot just by we'll punch that function in our calculator and going to our table and finding some points that will work and getting our graph from there. So it shouldn't be too bad graphing them anyway. All right, that's really all I have. Go back if you need to. Watch that second slide. It's all about the asymptotes. You've got to be able to find those asymptotes. I mean, you just got to. So we'll work on it tomorrow like we always do, and we'll get it. Got a good gesture for you, too. I know you can't wait for that. So see you tomorrow.